So sometimes things don't look like they're in quadratic form, and they are. So what we're really looking for when we're determining whether or not we're going to treat it like a quadratic is this ratio for the exponents of our variable to be in a 2, 1, 0 ratio. So it could be 2, 1, 0, it could be 4, 2, 0, or any variation of that where the ratio is the same. So let's look at an example that's like this. All right, now clearly you can see that's in a 4-to-0 ratio, which means that it might end up being factorable. Now, I will go ahead and point out right now, clearly we don't normally write the x to the 0. It's just equal to 1. So we can kind of ignore that, but I think it illustrates the ratio a little bit better. Now, what we're going to use here is called u substitution. And what I'm going to do is I'm going to just rewrite this as 4 blank squared minus 8 blank to the first plus 3, and I could do blank to the 0, but I'm going to leave that part out. And then I have to determine what could I put in here where those would be equal. Well, using my exponent rules, I would get x squared, and of course I can put an x squared there as well. And so in other words, I just need to find something or use something, a variable, to represent that x squared, and then I'll end up plugging it back in the end. And this is called u substitution. You don't have to use a u, you just use a variable. But let's see what happens when I perform that actual substitution. So anywhere there's an x squared, I can replace it with u. And so I'm going to do that. I've got 4u squared minus 8u plus 3. And I'm going to clean that up a little bit. And there we go. Now we can just factor this the way we normally would. There we go. And now I'm going to use the zero product property to solve for u. All right, now I know what u is, but I don't really care what u is, right? I care what x is. Fortunately, I know that for every u, I can just replace it with an x squared. So I'm going to do that.